record. I did a lot of talking there. I didn't record anything. So what we want to do is solve for x. Okay, so x is kind of buried down here in the denominator, right? And so we're kind of stuck. But you guys learned that if I was, I could always apply like an opposite mathematical process to something, right? To untie it. Right? So what I see here, I see 1 divided by, this is what I see in words in my head, right? 1 divided by 1 plus x. And so what you guys need to do is untie that. Well, what's the opposite of dividing? Well, it's multiplying. So I can multiply by, I'll try not to use an x, I'll use a dot. The dot implies multiplication as well. Okay, so opposite of dividing is going to be multiplying, so I'm going to multiply by 1 plus x. But you can't just do that for the sake of just doing it. There's a rule that you guys would have learned. What you do to one side, you got to do to the other. Okay, so the next line is going to look something like this. 1 plus x multiplied by a is equal to, now you'll see, anytime I multiply fractions, I have a 1 plus x over 1, right? These two things are multiplied. These are going to cancel. That's why we did this. We multiplied relative to the division that we saw, right? And so now we're going to see, okay, well, I just have is equal to 1, right? Because these two things canceled. And all I had left was the 1. Okay, and now I just got to solve for x. Well, okay, well, this is still kind of tied here on the left, but if I were to divide both sides by a, then I'd get these cancel, and I'd get 1 plus x is equal to 1 over a, which would then turn into, if I created what we called a zero pair, so those of you who don't know what a zero pair is, it's well, this is a plus 1, so if I can create a minus 1, and again, these two things would cancel now, or not cancel, but eliminate each other. And because they're opposite signs, but what you do to one side, you have to do to the other. So your final answer is going to be the 1 over a that was here, minus 1 is equal to x. Okay, does anybody have any problems with that? Okay, I'm just going to run you through a few of these. Okay, and there's some nice little subtle things in here that you guys may have forgotten about, as I don't know when you took math, right? The other thing is some of the grade 12s, the 4Us, it's like, say you didn't take, say you were under the benefit of having physics first semester of last year. We weren't under COVID. Okay, well, that's great, but it's still been a year and a half since you've taken physics, right? Now let's go, okay, well, maybe you took it in semester 2. We all know how semester 2 of last year went, right? It was basically a write-off, right? And I suppose my point here is that it doesn't matter when you took, we're all probably going to have some holes in our math, right? Or physics, if you've taken physics, just because of the circumstances that we've been under. Okay, so we're just going to review some stuff. I'm going to take it nice and slow, and I'm hopefully build you guys all up to a point that you feel confident enough to tackle some more challenging problems. Okay, so if there's no problems with that, we can look at the next one, right? This is, if you guys remember from math, and I've taught a lot of math, like all my whole teaching career so far has been teaching math, but you guys will remember something like this, right? Collecting like terms. And what that means is, okay, well, we got some numbers, right? We'll say the numbers are yellow, and then we'll say the things with X on them are green, right? And so collecting like terms means get all the green terms on one side and all the yellow terms on the other, right? And then solve for X accordingly, right? So that's what we're going to do. We're going to move pieces from one side to the other. Well, okay, well, I can create a zero pair here by adding 5, and I'm going to get AX. These now are 0 because it was a zero pair, is equal to BX plus 2 plus 5. Okay, well, that looks like I can do the math on that now, right? Well, it's 7. But I could still move this BX to the other side by creating a zero pair. So I'm going to get AX minus BX is equal to 7. And remember, the 7 just comes from, I'll use a different color. Not yellow. The 7 just comes from the 2 plus 5, okay? Now, we're at a bit of a crossroads, right? Because I can't really necessarily solve for x, because x is kind of tied on the a and the b. Okay, well, if I look at this, it looks like, okay, well, I have two terms. We call these terms, right? Each one. Here's one term and here's second term. I can do what we call factor, and I can factor what's common between both those two terms. Well, I see an x and an x, right? So I'm like, okay, well, there's an x in both those terms, which must mean I can take it out. What does take it out mean? It means divide both of these pieces by x and write it out front. That's what's happened, right? And so your end result is you're going to get something that looks like this, right? And you're like, okay, well, x still isn't by itself yet, but we're getting closer. What's to say you can't go like this? Divide both sides by a minus b. Now these cancel. Oh, look at that. X is equal to 7 over a minus b. Is there any problems? Okay. With something like this, you guys remember cross multiply. You would have seen a lot of this with setting up proportions and ratios and things like that, right? Proportional reasoning, right? What does that cross multiplication mean? It means that I'm going to take the 5 and I'm going to multiply it against what I see over here in the denominator, right? Across the equal sign. So I'm going to go 5 times 4x plus 8 has to equal, well, 3 times this piece here. 3 times 2x plus 6. And then you can do what we call distribution, right? Where we took the number out front and multiplied it in. Right? So we're going to see, okay, 20x, that's 5 times 4, right? And 5 times 8 is going to be 40. Okay, that just came from these two here, the 5 times the 4, and then the 5 times the 8. 20 and 40. Right? And that has to equal, well, we're just going to multiply that in again. We're going to get 6x plus 18. Right? And now we're in the exact same position that we were in up for this question. Right? We just got to get all the x's on one side and the numbers on the other. Right? And hopefully, this is, I've started slow. Hopefully we can start to move a little bit quicker with some of this math. And we can do two things at once, right? Well, I know that I can create a zero pair with the 6x here. Maybe I'll do it in a different color so you can see. Minus 6x. What I do to one side, I got to do the other. But I also see, okay, well, I've got a plus 40, which means I can subtract 40. What's the end result? Well, I get 20x minus 6x is equal to 18 minus 40. And you just do the math, right? Okay, well, 20x minus 6x, that's going to be 14x, is equal to 18 minus 40 should be negative 22. Get x by itself. How do I get x by itself? Divide both sides by 14. Right? So I get 14x over 14 is equal to 22 over 14. And my x value should be, oh, sorry, I forgot a negative. What you guys will find too, good talking point here, it's very easy to forget a negative sign. The thing with physics is it'll just create a disaster for your answer. Right? You got to be very, very careful with physics, and in particular, like if you look back at this morning's lesson, just forgetting to put a negative on something because a force is acting or a displacement is in the negative direction completely changes an answer. Now you're adding instead of subtracting, right? And you get a completely wrong answer. So you can only imagine as these questions get more complicated how one negative somewhere trickles through an entire question just because something silly has happened at the very, like you forgot to put a negative on something that's acting in the west direction or something, right? Or south. It'll mess up an entire question. Okay, so then that's that. You could reduce that to be, if I divided both of them by 7, or by 2, you get negative 11 over 7. Okay? I don't want that there. Okay. This one, there are some subtle things in here that are useful. In particular, if you guys pay attention to the order in which I'm doing things. And again, like maybe some of you are better at this than others. Like I remember having no idea what was going on sometimes when I was doing math. I just kind of did it in whatever order I wanted. Remember, when you guys are solving for things, you're always kind of like, something that kind of got neglected when I was going through math, I suppose. It's like everybody's good going this way, right? But to solve for something, you go the opposite direction. Okay. So I see here, like they can't do anything. There's no addition subtraction because it's in, well, there is, but it's tied within inside the bracket, right? So the first thing that we're going to have to do is divide both sides by L naught, right? That wipes that out. And so now I'm left with L over L naught is equal to 1 plus alpha t. And don't be scared by these are just silly variables that my grade 12 teacher came up with. They don't mean anything yet. They're just whatever. Don't be freaked out. Okay? They're just, alpha is a Greek letter instead of, it's a Greek letter for the letter A. It doesn't matter. Okay? Now that I've gotten rid of that bracket, right, because I divided, now I can untie this subtraction, right? I'm like, okay, well, I can move that over by going to -1, right? Alpha's not yet by itself. So I'm like, okay, well, I can divide this side by t. What I do to that side, I have to do to the other. Okay, and there's your answer. I'll leave it like that, okay? So we got L without overcomplicating it. -1 all divided by t. We will do some more work involving simplifying fractions with inside fractions, okay? But just for today, I just want you guys to remember some of these math skills, okay? Anybody have any questions before I get too carried away here? I'll try to make this smaller. Save some space. Now, I'm not 100% sure as to whether or not the 4Cs have seen this before, but probably. I know you've done quadratics. Okay, this is a quadratic, and I know you've all done quadratics to death, probably, right? The 3U's anyway. This is a quadratic. You guys know quadratics as being a parabola. It looks something like this, right? Or like this. In this particular case, because there's a positive out front, the parabola is opening up. Right? Just fine details here. But you guys spent tons and tons of time working on quadratics in different scenarios, solving for different things. When I solve for x here, I'm solving for the roots or solutions, right? Or x-intercepts or zeros. Those are all four. They're the four, they all mean the same thing. They're just where the graph crosses the x-axis. Okay, and we're going to see where that comes into play later. Now, there was a couple different ways to do this. One of which would have been, okay, can I factor? That was always the number one thing that you guys were asked to do is, can I factor this to make it like easier? Sure you can. Well, I can. It looks like all of these are divisible by 2, so I can remove what we call the greatest common factor, right? X squared minus 6x minus, oh, sorry, get carried away here. 3x minus 9 is equal to 0. Right, and then you guys ask the question, okay, well, how can I make this easier? Well, you had this like man method, right, where we were trying to find two numbers that multiplied to -9 and added to -3. Right? And you're guessing. You're like, okay, well, 1 times 9, that's not going to work. 3 times 3, that's also not going to work. Okay, well, it was at this point when you couldn't find two numbers, we said this wasn't factorable. Okay? And for, let's say, a factoring test, that would have been fine and dandy, and you would have said, okay, there's your 3 marks, move on. But we also would have taught you at some point about this nifty equation that always works. And we call it the quadratic equation, right? And it takes the form of something that looks like this. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay? Now, what I will do at some point is like, you guys can use this to help you with the physics questions, right? We're going to use this because we would have seen that, like, at least in grade 10 math, academic math, when I do this, we talk about a ball getting thrown, right? And how long does it take to hit the ground? This is basically a math question you guys have seen before. Like t equals, I don't know how long. That's all it is. You guys know how to do this. Here's an equation. You've got, you'll see here, if you guys remember the standard form of an equation, took on the form y equals ax squared plus bx plus c. Maybe I'll take that, move it up here. Right? Where you can see each of the numbers. Before we factored it, it would have been, okay, there's a 2, b is negative 6, and c is negative 18. So you would have taken those numbers and plugged them in, right? And you would have found what the x-intercepts were. Okay, so that's what you're going to do, except we've simplified it so the numbers aren't as big, right? And so we're going to go, okay, x is equal to negative, what's the b value? The b value is, maybe I'll highlight some stuff here so you guys can see where stuff is coming from. Right? You're just going to put the negative 3 in where you see the b values. Well, now I see an a. Where's the a go? Well, what's the a value? Well, it's an imaginary 1. So you're going to put a 1 in where the a is. And what's the c value? The c value is negative 9. That's all you're doing. It's just tedious work, right? But it'll always give you an answer. It's a little like, this is a little tool for like harder kinematic problems, which we're going to see hopefully by Friday, some of Monday. Okay. So we can say, okay, well, what's going on here? Well, we go negative 3 plus or minus 3, negative 3 squared minus 4 times a is 1, b is negative 9. And that's all divided by 2 times the a value of 1. Right? So negative and a negative, that's going to make 3 plus or minus square root of 3. Negative 3 squared is going to be 9 minus 4 times 9 to be negative 4 times negative 9 is going to be negative 36. It's minus makes it plus 36. 2. Okay, if you guys did the math underneath the square roots, you'd get 3 plus or minus whatever that number is, all divided by 2, right? Square root of 45. And you find out that x can equal whatever it is. Okay, I'll show you guys later. If there ever is a question that we need to do something like this, I'll show you guys how to do it in your calculator so that you don't have to do this every time. It's laborious. It's easy to make a sign error, right? For what? It doesn't, like, I'm not testing your math skills per se. It's the application of the math skills, right? So just knowing that you need to use the quadratic equation for this particular question is good for me, right? And so being able just to type it into your calculator and the calculator give me the answer, that's what matters, okay? If there is ever a time I ask you to do this question. Okay, does anybody have any questions so far? Done a lot of talking, okay? I'll try to power, there's only a couple more things here, okay? I tried to go a little bit slow but fast with all that, okay? There's two other critical skills that you guys need for this course. Well, okay, we got a general question. Where are you going to submit stuff? So what I'll do is create like an assignment tab. You guys will see it come up. And I'll post the assignment there, and you'll submit it right underneath it. I just haven't created it yet. Right? And you're only submitting formatives and summatives. Okay, I'll create, you'll see it come up. It'll be in the top top banner. It'll come up beside content. There'll be an assignment thing. You'll click on it, and then you guys can see, you'll see everything come up. And you just go into the assignment and then hit submit. We'll have a conversation around how you guys actually submit stuff, because I don't want a whole bunch of pictures and stuff. But no, you guys don't need to submit homework. That's what the office hours are for. You guys are starting to become a little bit more independent from the standpoint that, like, there's a direct connection between you guys practicing problems and then what you're going to see on a formative or a summative eventually, right? So it's in your best interest to try the homework questions and come to the office hours from 12 to 1 if you have questions, okay? You guys will there will be hard questions that you guys will need help with, okay? And that's what the office hours are here for, okay? But if you don't do any homework, like, it's not going to go well for you. Okay, you guys can try this stuff. So we're starting easy. Just kind of ease you guys into some stuff, and we'll see how it goes, okay? But I'll be able to see whether or not you guys know what you're doing or that you've been doing homework based on the formatives, right? And that way I'm not getting 4,000 submissions of homework, right? Does that answer everybody's questions, okay? So we have two more kind of key things here. Okay, and we're going to do this question 2 ways to show you that it can be done 2 ways, and it's kind of your preference, but you need both of them, because sometimes we talked about their applications being better in certain instances, right? All of you would have seen this 100%. No questions. If you're a 4C, 3U, you've all seen this substitution, okay? And that's what we're going to do first, okay? This is a very useful skill, right? When I see 2 variables here, like I see a t and an a, right? This would be a very easy question. I'd be able to solve for a if I knew what t was, but I don't, right? But they've also given me a second equation here with the exact same variables. So what you guys have learned in your math class, whether it be a grade 10 applied, grade 10 academic, doesn't matter. You would have learned this skill of isolating for one variable. So for this question, I'm going to isolate for the t that's sitting here. So t equals, what's t equal to? Well, I'm going to create a 0 pair. I'm going to add 49 to both sides. I'm going to go 5a plus 49. That's what t is equal to. Now you would have all learned to take this t value and replace it up here where you saw the other t. This is what we call substitution, right? What you're going to see after I do that is I get 98, that's nothing changed, minus, nothing's changed. What's t equal to? T is equal to this piece. So you're going to replace it. Okay, this is t. That's right here. Okay, now I don't see, I just see a question that we saw up here. I see one variable to solve for now, right? I see a. I just see a in 2 spots. I'm just gonna clean it up, right? So this is just math, cleaning it up, right? So I'm just trying to get rid of some brackets here. I'm gonna distribute the negative in, and I'm gonna get 98 minus 5a minus 49. That's equal to 10a. Okay, and I'm just going to get the numbers on one side and the a's on the other. That's it, right? So, well, the numbers are conveniently already on the left side, so I'm going to leave those alone. And then the opposite of subtracting 5 would be to add 5a. Sorry, 5a would be to add 5a. And so you're going to get 98 minus 49 is equal to 10a plus 5a. You have 49 is equal to 15a. solve for a. Divide both sides by 15. I think I had a was equal to 3.2 or something like that. I did the math beforehand. Thought I did anyway. Maybe I might be right. Yeah, 3.27. Okay? Once you have that, you care about what the other variable is. In this case, it's capital T. Right? You're like, okay, well, how do I find T? Well, you have an equation that tells you what T is equal to. It's right here. T is equal to 5 multiplied by the A value that I just found, 3.27, plus the 49. So you just do the math. Type it into a calculator. You're done. T should be equal to, it's stuff all over the place. T should be equal to 65.3. Now, you will see tons and tons of scenarios across this course where you need to rearrange an equation and substitute it into another one, right? Or at least be familiar with rearranging equations in order to solve for one variable versus another. You have to know how to do that, which is why we're doing all this work. One of the other skills that you need, and you will see it come up in its appropriate instance, is you guys would have seen something called elimination, hopefully. And most of the time in my experience teaching some of the grade 10 academic course, the kids like elimination a little bit more than substitution conceptually. It's just easier to see, right? And so what you guys can do is we take the two equations. Well, I'll rewrite the first one. You can rewrite the equations. Remember, if I'm adding things, it doesn't matter what order I add them in, just that the signs follow them. So I can go negative t plus 98 is equal to 10a. That's the first equation. That's this one. Nothing's changed. And then the second equation, I'll just rewrite again. T minus 49 equals 5a. Now, elimination says, okay, well, I have two equations stacked on top of each other. And what you've done is you've lined up A's, numbers, and T's, right? You've lined them all up. And you're going to try to eliminate one of the variables. Well, it looks like I have a negative 1t plus 1t. So negative 1 plus 1, that's equal to 0. So if I add these two equations together, or basically collect like terms, if you will, if I add them together, I get a negative 1 plus 1, that's 0. 0t. 98 minus 49 plus negative 49, if you will, is positive 49 is equal to 10a plus 5a. That's 15a. You'll see I get the same work that I got over here, where 15a was equal to 49. I got 0t here. It's gone. It's eliminated. That's what we did. Right? So now you're saying, okay, well, I've got 15a is equal to 49. So a must equal 3.27 when you divide both sides by 15. And then you do the same work. You already have an equation. You just take a and replace it in one of your two equations and solve for t. I know it's starting to get messy. Okay, it's the exact same work. You know what a is numerically now. So plug it in there and solve for t. One of them. You guys will need to know how to do that for sure. But later, and we'll do more questions, obviously. I'm not going to expect you just to pick that up and go. I'll show you the math again in context relative to a question. That should look pretty familiar to all of you, most of you. Again, the 4Cs, I don't know when you would have come across elimination if it's in a 4C math course. I don't know if it's in the 3C. I can't quite remember. But the quadratic stuff is, for sure. Okay. The only other thing you got here is how to apply exponents. And you guys will see in your note, I fixed it. I didn't fix it in mine. You'll have a little squared there. And essentially what this means is exponents mean power laws. You guys would have seen some of these, I'm sure. Right? This physically means you're going to have negative. It means that there is two of them. Right? Two of those multiplied together. So 4x4 y2 multiplied against negative 4x4 y2. That's what it means. Okay? This is the long way to do it. You guys have also learned some power laws. All of you should have learned power laws such that anytime you have an exponent raised to an exponent, you're going to multiply the exponents together. That's the faster way to do it, right? On this negative 4, just as a side note, there's a little exponent 1. So your next line here would be negative 4. 1 times 2 is going to be squared. X, 4 times 2 is 8. Y, 4. This is also worth mentioning because this is going to come up. I'm sure this is going to come up. It's going to mess up somebody's answer. When you guys type stuff in to your calculator, if you go like this, what the calculator is going to do is it's going to square the 4, and you're going to get negative 16. We all know anytime you square a negative, like you know, what did I just finish saying? Negative 4 squared is the same thing as negative 4 times negative 4. What do you get when you multiply two negatives together? Positive 16. But I guarantee somebody's going to type it into their calculator like this, and they're going to get a wrong answer because it's going to spit out negative 16. You guys got to be careful. Now you're going to ask yourself, okay, well, what do I do to prevent that? What you do in your calculators, and hopefully you've all got scientific calculators, you go bracket negative 4, bracket, squared. Now the squared is going on two things. You're going to get positive 16. Okay? You got to be careful. Because we all know two negatives make a positive, but inevitably I'm going to see somebody write this, for sure. And it's going to mess up your answer, which is why I'm talking about it. Okay, it's got to be positive 16. One more, and then I got one little lesson thing for you, and then we're done. Okay, this is your homework underneath this black line. Okay. Anybody have any questions? Okay, I'm just going to apply the power rules again here. So this one's got a little bit more complicated. Okay, so what you've got here, I'm just going to apply the negative 3 to everything that I see. Okay, so I'm going to get x 2 times negative 3 is going to be negative 6. Y to the negative 12. All I've done is multiplied the exponents. That's going to be divided by x to the negative 3. Y to the positive 6. Now, you guys should have learned, anytime you see a negative exponent, you can flip things around. Top to bottom. And it becomes positive, right? So you're gonna rewrite this. I can bring the x cubed, x to the minus 3 to the numerator, right? So x cubed over, I get x6, y12, y6. Okay, and then bases that line up like that, you add the exponents. So your final answer here is going to be x cubed over, oh, not quite the final answer, sorry. There's one other thing you can do. 3 of these cancel with 3 of those, and you're going to be left with 1 over x cubed y to the 18. Right? Any problems? It's a little bit harder of a question because the negatives are in there. We might come across some negative exponents somewhere. Well, you guys just have that skill now. Okay, I don't expect it. Obviously, if I'm reviewing all of this stuff, it's going to come up. So you're going to see me do questions by applying this math somewhere. It's not as if I'm expecting you just to pull this out of your hat and then be done with it, right? Like, we're going to get more reinforcement and more practice with this math as we do physics problems, right? My goal is by the time you guys get done this course, you just, now it's like, oh, this is quadratic equation, or like substitution or elimination. You're applying some math skills that you've had or been taught in the past, and we're putting them into context in physics problems. Okay. Now there's one more thing, and then we'll be done for today. I know I said to be faster than that, but there's one more thing, and this is a skill that I wish I had sooner, before I got to university, because they showed it to me in university and I didn't have a time to appreciate it. Okay. What we can do, and this goes for like, it doesn't matter if you're taking chemistry, if you're taking physics, it doesn't matter. There is a story to be told in the units, and that's why we emphasize it from a physics perspective, but also in math. Like, we emphasize units in math, but we don't really provide context to that. Physics provides the context. What you'll see here, and this is what we call dimensional analysis. Okay. Where we take something and we look at the dimensions that it's going to have. Dimensions basically means, what are the units something's going to have. Okay. And so typically, we saw this morning, velocity or speed was distance divided by time. And so its dimensions would be the distance and time. All right, or what we denoted. We saw this morning. We denoted distance as, what was its unit, or its symbol? It was d. And time, we saw that its symbol was capital T, or little t. They use the capital because you could have time in like milliseconds or whatever, right? But t is just like the parent to time is time. It's just time, right? Doesn't matter what the units are yet. It's just dimension. Okay. Now you're asking yourself, okay, well, what good is this, right? Well, if I took a question like what's below here, like the period of a pendulum, right? It's saying t, the dimension t, this is time. So it's saying, okay, capital T. This is what I mean. So it's either in seconds or milliseconds or something, right? It's saying that the units should be a time for the period of a pendulum. Okay. Now, what you guys can do, yeah, Elizabeth, this is like capital T is like temperature. If I was talking about temperature specifically, capital T here in this context, I suppose you could say a capital T with bars around it represents the dimensions of time. Okay, it's just sometimes we run into issues with the way we label variables, like cross one another. Okay, but the period of a pendulum is just something that swings, like a grandfather clock, right? A pendulum that swings back and forth. It has a time for it to reach one side and then back to the other. That's the period, right? This is the swinging motion. How long does that take? Because it's time. We're talking about time, right? And so what we want to do is prove that this little equation on the right actually gives you the units of time, seconds, or whatever it is. And so that's what dimensional analysis does, is it looks at any equation that you're given, in this course for sure, the dimensions will match. So if you're given an equation to solve for time in this particular question, then the work on this side better work out to give you time. And it'll mean more to you in a second. Like if I look at these homework questions, I see x, so x is measured in distance. So then these guys over here better work out to be a dimension of distance, if it's meters or kilometers or whatever it is, right? Well, you'll see in a sec, okay? It's a useful tool from the standpoint that, like, if ever you're stuck, and let's say I didn't know what the equation was that I was supposed to use, but you know what it is you're looking for. Like, let's say I know I'm looking for velocity. You know that the units for velocity, and this is why I think teachers, if you guys remember this DVT triangle, right? That's why teachers don't like you memorizing it. There's value in understanding what it's doing. Velocity, you guys know that from this morning, we're expecting meters per second, or d per unit time. So some distance per unit time, right? Well, I know that's where the triangle came from. We've written the triangle right here. V, if I were to cover up the triangle, it has to be distance over time. That's where it came from. All that we're going to do is make the equations more complicated. It does not change the fact that if I end up with a distance over here, all of this side has to also give me a distance, so that when I get my final answer, if you know that distance is supposed to be in meters, your answer better be in meters. That's what dimensional analysis is doing. But its tool is, like, if I look at a question and I don't know the triangle, but I know what dimensions the answer is supposed to be in, and I look at what's given to me in the question, then I can use the units to solve the question by forcing it to work out by, okay, well, I need to multiply these two things together to get the units to cancel, right? You'll see. Okay, we'll do this question now. That was a lot of, like, lots of words. Okay, I'll actually do this question. So we're looking for units of t, or time, seconds, right? Whatever the time is. So we need 2 pi. And then this question tells us, okay, well, d is going to be that kind of d, like it's a meters or something like that. And then g, you guys don't know what g is yet. G, we're going to do tons and tons of this, so it doesn't matter. G is acceleration, or let me write this somewhere else because it's kind of already. Don't worry about this. We're going to do this for days after this, okay? G is the acceleration due to gravity. Okay, and we haven't yet. We're going to do this tomorrow, but we're going to see acceleration. The units for acceleration would be something like meters per second squared. It would be a typical acceleration. And so if I were to write the dimensions for that, I would get meters. So meters is a distance. And seconds, so seconds is a time. Squared. Can't forget the squared. Okay, and so G, you're just going to substitute that in there. D per unit time squared. Right? And the square root's going to hang over top of all of it. Now, for the purposes of dimensional analysis, 2 pi doesn't have any dimensions. It's just their constants, right? Pi is just a number. The number 2 is also just a number, so this doesn't affect anything. The only thing that gets affected is this stuff on the inside of the square root. So now you're going to say to yourself, okay, well, this looks disastrous, right? And it does a little bit, but you guys have a way of dealing with what this is a fraction inside of a fraction. Okay, and the way we would have dealt with something like this in the past would have been, no, not over 1, sorry. We take whatever's in the denominator, we can bring it to the numerator and multiply by the reciprocal. So what we're going to get d multiplied by t squared over d. So you guys can see I've taken it from the denominator and I've moved it to the numerator, and in doing that I flipped it, and this is all square rooted. Now you're multiplying fractions. Well, d's cancel with the d. And what are you left with? You're left with the square root of t squared. Well, if you square root something that's squared, like for instance, what is the square root of 6 squared? Well, the square root of 36 is 6. So that must mean that the square root of t squared is t. Well, look at that. This matches this. So we know that this equation, through dimensional analysis, is dimensionally correct, right? Like the units that I'm going to get using this equation is going to match what it is I'm looking for. It's a very powerful skill whenever you don't know a particular equation, right? If you're ever stuck, you can always force it to work by looking at what you're given in the equation and knowing what the units are and looking for how can I combine the stuff that's given to me to make it work out to the units in the question of the thing that I'm looking for. Okay, hopefully that is kind of clear. 2 pi. Oh, the 2 pi is just, what is 2 pi? 2 pi is just a number, right? It'd be 6. Like you wouldn't tell me that 2 times pi would be like 6.28. But there's no units. Like you wouldn't tell me that it's 6.28 meters per second or anything like that, right? Like it doesn't have units. So for the purposes of dimensional analysis, it doesn't affect anything. So we just ignore it. It doesn't, well, it's not a part of the dimensional analysis. If I was looking for a numerical number, then yes, you would have to include the 2 pi. Like if I wanted an answer of something, like in seconds, you'd have to include the 2 pi. But if I ask you about dimensional analysis, which I will, it'll be a simple one. I just want you guys to check to make sure that the units that you're going to get match left and right side. It's like a check, right? Which you guys would have done in doing substitution elimination when you check your answers, right? You're checking left side equals right side. That's all dimensional analysis is doing. It's just saying, I don't care if it's meters per second or kilometers per hour. I just want to check that its speed equals speed. That's all you check. That's what dimensional analysis is doing. Checking the dimensions. Is that okay? That's pretty much all I have for you today. You guys got a couple questions there. I want you guys to practice doing some dimensional analysis with these questions. And then if you guys need it, practice your substitution skills. Okay, just practice rearranging things. And if you need, if you guys need to watch how to do that question, those 2 questions, you guys can take your camera. I'm sure you guys know how to use QR codes. If you guys scan that, right? If I put my phone up here, it'll pop up open in Safari. It'll take you to the video of me doing those 2 questions. Oh, never mind. I might have to change it. I signed up to get a fancy QR code, and then I didn't pay for the extension, so it didn't work. I'll post the videos for those, and mine's online, okay? And then if you guys need to watch them to do that, you guys can watch them if you're struggling, okay? Is that okay?